This side-by-side data visualization shows the current state of enterprise AI. On the left, we see a rapidly rising curve, where over 75% of large companies have adopted generative AI tools. But on the right, the flatlined bar chart reveals a severe conversion problem. More than 80, they became cash accretive in 1 to 2 years, generating $3 of earnings for every single dollar invested in AI. Measuring software usage produces a false signal. High activity metrics, like seat counts and prompt volumes, can mask the fact that an organization has failed to capture any real financial return from the technology. Foundation models and copilots are widely accessible infrastructure. Because this is available to every large company simultaneously, model access provides no durable competitive moat. Competitive advantage now depends on enterprise rewiring capacity. The organizations that succeed will be the ones that can redesign workflows, build reusable data assets, and force adoption into their operational models faster than their peers. This diagram outlines the core thesis of AI value. At the base, we see the common failure mode, scattering individual tools across thousands of unchanged workflows. Gaining an advantage requires moving up the structure to concentrate capital into a few highly specific economic domains. The organizations achieving the highest returns isolate 2 to 3 specific areas where process change directly moves the profit and loss statement. They enforce strict workflow redesign within those targeted zones, rather than spreading pilot programs thinly across the entire company. If model access is common, then financial outperformance is a function of how narrowly and deeply a company integrates those models into its core domains. Value comes from this concentration, not from a mandate of AI everywhere. The default state is operational theater. Leadership teams celebrate slick dashboards displaying tens of thousands of active users and millions of generated prompts. But when asked to bridge those metrics to the profit and loss statement, the math disappears. This funnel maps the structural reality. It shows the specific operational joints where capital enters the system and exactly where it leaks out. We start at the top, where board-level ambition translates into a major capital injection. The initial mandate is funded. Immediately, the capital begins to bleed out. The ambition is fractured into scattered pilots without clear economic owners. Then the tools are layered on top of legacy processes that haven't been structurally altered. Value escapes at the points of integration. The remaining investment trickles down into custom, unscalable data extracts. When role expectations and human incentives are left untouched, usage remains voluntary. By the time we reach the bottom, the actual financial output is non-existent. The mechanical reality is unforgiving. Making an inefficient legacy process run slightly faster by dropping a language model in the middle of it yields the same underlying economics. Enterprise AI projects do not fail because the models are incapable. They fail because the business operations surrounding the model refuse to change. Stopping this leakage requires shifting focus to the mechanics of workflow redesign. The human steps, approval layers, and data handoffs must be remapped. This flowchart demonstrates the failure of the standard copilot model. A new AI tool is dropped onto a middle step to help draft or retrieve information, but the surrounding process structure remains locked in place. The AI might complete its specific task in seconds, but the human touchpoints, review cycles, and cost structures upstream and downstream have not shifted. The human processing speed remains the bottleneck, negating the technology's speed. The alternative is bounded autonomy. Here, the workflow is aggressively redrawn. The AI becomes the primary executor of the entire process loop, operating within strict rules, while the human role is shifted to manage exceptions. We can observe this dynamic in the physical world. Consider predictive maintenance inside a massive, heavy manufacturing environment. An AI model might perfectly predict when a critical machine is going to fail. But if the maintenance crew still operates on a rigid calendar-based schedule and the procurement team hasn't updated how they order replacement parts, the financial value is zero. The technology cannot capture value in a vacuum. The human incentive structures and operational systems must be rewired to absorb and act on the AI's output. This chart visualizes the widening gap in total shareholder return between digital leaders and laggards. This advantage compounds. When a company successfully rewires one economic domain, it creates reusable assets. data pipelines, deployment patterns, and governance models that make the next deployment cheaper and faster. Laggards experience the opposite. Because they fail to build an underlying structure, every AI project is an expensive, bespoke prototype. They start from scratch every time, generating zero reusable data and extending their cycle times. Overcoming this requires a 6-capability AI operating system. This architecture builds from the bottom up, establishing a foundation that turns individual projects into an industrialized process. The base layer is critical. Owned, certified data products and a unified technology stack ensure that the engineering work done today feeds directly into tomorrow's, driving the marginal cost down. Market-leading value capture does not come from managing a disjointed portfolio of IT experiments. It requires building an integrated enterprise operating system. The need for this operating system is accelerating due to the rise of agentic AI. We are moving beyond models that simply draft text in isolation toward autonomous agents capable of taking cross-system action without human supervision. This introduces a severe enterprise control problem. When an AI agent has the autonomy to route a customer, alter a financial forecast, or execute a supply chain order, determining who governs that action becomes a matter of operational risk. This architecture map shows an agent attempting an action inside a core system. The first critical junctions are identity and routing, but the most crucial control point is durable write-back. The software layer that captures the permanent state change defends its margin pool. Strategic power is shifting. While model intelligence is a commodity, the platforms that control identity, exception routing, and the final execution of work will capture the majority of the margin pool. For institutional investors and board members, the challenge is cutting through corporate narratives to find true economic transformation. This AI diligence filter separates rewiring from theater. Red flags include AI everywhere, CIO-only ownership, manual data extracts, and measuring success by seat counts. Green flags are 2 to 3 specific domains, business-led P&L accountability, and a direct EBITDA bridge. Real structural transformation rarely resembles a flashy technology demonstration. It is often narrower in scope, slower to start, and deeply operational. Investors must discount broad usage metrics and demand proof of structural accountability. If the operational system has not changed, the economics will not change. True enterprise advantage in the age of artificial intelligence belongs to those who stop buying more software tools and start doing the uncompromising work of rewiring the business.